Hello, everyone, and welcome to today's webinar. My name is Margot Newcomb. I'm a Director of Marketing here at Teledyne Marine. Today is the last of our three-part series dedicated to our Blueview 3D technology. Hopefully you've been able to join us for our first two sessions, but if not, they are recorded and available on our Teledyne Marine channel. So great if you can go back and check those out if you missed them the first time around. Today's topic, we're going to be focusing on point cloud post-processing. So as usual, we have John Robertson and Tyler Whitaker here, and they are going to share their vast knowledge on this topic with you. It sounds like it's kind of a whirlwind here with a lot to cover in a short amount of time, but I am looking forward to hearing what these guys have to present today. So before we get started, I do have a couple of housekeeping items for you. Number one, as usual, this session is being recorded. You will get an email within the next 24 hours with a link. So if you need to log off early or want to share it with a colleague, you will be getting that email with the information. And also, as usual, everyone is muted to keep our background noise to a minimum. However, we will be doing a Q&A at the end as usual. So as we go along, if you have questions, please do type them into the question pane. If it's something immediate and you're hoping that you can hop in as they're talking, you can even raise your hand. There's a little button where you can raise your hand, and John can see that as well. So it could be something that he can kind of stop as we go if it's something urgent as we move along. Otherwise, type them in and we'll take them at the end. And with that, I'm going to hand it over to John and Tyler.
Thanks for the introduction, Margot. And as Margot mentioned, we're basically concentrating a full day of data processing and data review and cleaning into this 45 minutes. So we're going to try to compress that full day training section into these 45 minutes. So if there's anything that you need more detail on, or you want to get more information on a specific part or a specific process, let us know, and we can potentially set up another session with you individually, or have another focused session on that topic later on. I'll spare us from the introductions of Tyler and myself in too much detail, but we've been here for a significant amount of years, starting with both of us starting with the Blueview brands, and have extensive field experience with these systems. So we'll try and pass on as much information on this topic as we can today. So Tyler is going to be controlling our screen today and going through some data review and processing. So we'll jump right into it.
All right, thanks guys. So yeah, I am going to jump right in here because there's a lot to go over. Today we're just going to be reviewing point cloud post-processing. So up until this point, we've discussed for the 3D product, the BV5000, we've discussed the hardware itself, ProScan, which is the data acquisition, and now point cloud post-processing. So as I just mentioned, we can see kind of the software data flow here. Last week we discussed ProScan. You can go back and watch that if you missed it. And now we're here on Stitch or registration or post-processing, you know, whatever you want to call it. And then of course your final deliverable, which is generally the point cloud. So this processing step can be done with a number of different software suites. Like I've mentioned, it can be done with Cloud Compare, which is a free kind of open source software. It can be done with, there's Leica, Geosystems makes software. There's a lot out there. We've kind of been selling software called QuickStitch. It was kind of made with the BV5000 in mind, so it has it's stripped away a lot of the tools that might overcomplicate the process. And it is the software I'm most familiar with by far and have used the most. So it's what I'm going to be using to review. So just keep in mind, every software, like Cloud Compare, for example, will probably have a different layout of tools. We'll have different ways of going about certain processing steps, but ultimately it's doing the same thing. So with that, I'm actually going to just jump right into the software itself. Can you guys see the software window?
Yeah, I see it now. Yep.
Okay, blank. There's no data in there yet, but okay. So here's Quick Stitch. This is basically the main UI. Once you open it, this is what you're met with. Obviously no data in here at the moment. So the very first step generally is going to be just to add your XYZ file. I can do that through File, Add XYZ. I have a data set here we're going to be working with. It was collected in Alabama a while back. It's in kind of a quarry or dam outflow area, if I'm correct, John.
That is correct. Yeah, these are dam outflow tubes. There's three gates that you'll see in the data set that you can point out, and from different scan locations. So we'll merge multiple scans together to fill in the whole area.
Correct. Yeah, so here's one data set. So this is one scan location, one point cloud. We can see kind of the trademark donut hole or blind spot where the tripod was actually located. And we can see the surrounding area. So right off the bat, we can see it's an area with 3 kind of close walls and then no back wall here. What we'll find is I bring in the other scans at the other locations are 4 locations. So there's scan location 1, scan location 2, 3 would be about here, and 4 would be here. So presumably that would be during acquisition written out on a map so we know which location corresponds to which area. This is kind of a small area, so it's not too hard to figure that out, but on larger data sets with more locations, you'll definitely want a good scan location map. So first off, I want to go over just the tools kind of up here at the top, just with the single data set. So moving across, we have kind of file tools, so new project, open a project, save, of course. 3D view, which we're in right now. We have a 2D view, which will basically remove the Z coordinate and make it just a 2D kind of plane, X, Y. Back to 3D. We have a side view. We'll basically lock into a side view. We have an align north up. So these are all just kind of view controls. Few that aren't particularly used. We have a bounding box. We have kind of a surface grid we can enable. Let's turn this off. Surface grid. We have background maps kind of built into the software. So if you are connected to the internet, you can, for example, click a Bing satellite map. This isn't a georeference point cloud, so it's going to be located in the middle of, actually this looks close, in Alabama somewhere. So, but if you do have a georeference point cloud, it will be kind of overlaid correctly. And if you are in the correct coordinate system set up here in settings under geodesy, then it will kind of overlay properly. So number of maps here can make for a nice presentation. If you're doing screenshots or videos, it's nice to have data in the back here. So again, that does require an internet connection. For simplicity, I'm just going to do no map here. Measurement tool, of course, it's very useful. Blueviewer did have a measurement tool as well, but Quick Stitch has kind of a more powerful measurement tool. So if I click measurement, it brings up a little dot here. So start measurement and measurement. I can hit the escape button to kind of clear it, and we have the measurement actually staying on the point cloud. And we can see on the left here, it actually shows up as an item, as an object, measure 1, which I can actually name. I can call it, pole or whatever you want to call it, with all the actual properties down here. So good simple measurement tool. I'm going to remove that just to clean it up. Moving along here, we have a profile tool, which is an incredibly powerful tool. So it basically pulls up a cut here, a profile cut view. So down at the bottom, let me make this a little larger. We basically have a kind of a profile of the point cloud, as we can see represented here. So if I actually click on the profile, I can move it to kind of move through the data itself. This is really good just for kind of data analysis. It's really useful for point cloud registration when I have 2 point clouds together and I want to verify that they're registered properly. I use this tool just to make sure, you know, for example, the wall is lined up or the bottom is lined up. So you'll see me using this tool probably at least once more today. There is a axis profile. So if I do this, it basically does two profiles, and an X and a Y. I can kind of move this around the data set as needed. I don't use this as often, though it is a useful tool if you want to just have profiles in both X and Y axes. You can do things like set waypoints. I'm not going to really spend time on that. Of course, screenshots, incredibly important, self-explanatory. Click the screenshot button, you get a capture of what you're currently seeing. Camera keyframes, I will go over these later. This is when we're doing video fly-throughs, when we're basically making a movie. This is very useful for deliverables if you want to have a quick video fly-through of the point cloud to send through email or whatever else. This will be the tool we'll use, so I'll definitely be reviewing that. Export XYZ, so let's say I've cleaned, registered a number of point clouds, merged them into one point cloud. I can then export and save it as a new XYZ with this export function. Optimization, this is can be quite important, especially with denser data clouds. So basically, for a system like the BV5000 that's pinging 30, 40 times per second during a 1 degree per second scan, for example, that's a lot of data points. In fact, that's typically more than a lot of users require, and it really can bog down processing, making your computer, if you don't have as good of a processing computer, which ideally you do, but if you don't, it can really kind of slow down the processing and make it harder for your computer to render. So a good first step is just to click optimize. It will basically default to 1 centimeter. And what this means is it's going to remove any point that's closer to its neighboring points by less than 1 centimeter is going to delete and basically thin out the points. So if I click OK here, you can kind of look at the point cloud and see if you notice any change, and more than likely you will not. So let me click OK. It's removing points. And we're done. So it removed 384,000 points. If I click OK, again, I didn't really see too much of a difference, and that's pretty typical. Like I said, this data is incredibly dense. There's in a data set like this, there's hundreds and thousands, millions potentially of points. So optimizing it, thinning it out a bit is not really noticeable, but it will make it much easier to deal with. So good first step in the workflow here. Increase point size, decrease point size, also self-explanatory. I typically like to work with smaller points. Ultimately, it's up to personal preference or how you want the data to be represented. Align, this is the main point cloud registration function, so I'll be going over this in just a bit. And then we have a transform tool and a select tool. So transform tool is actually just it's a movement tool. So I get these controls that pop up. Let me zoom in a bit. So we kind of have a number of controls here. We have controls for each axis. So if I click, say, the green arrow, it's going to move just along, say, the y-axis. If I click the red arrow, x-axis, the blue arrow, it's going to move just along the single axis. So single axis movements are these arrows. And then if I click these kind of yellow handles, that's going to be double axis movement or movement along a plane. So here's along the YZ plane, the XZ plane, and then the XY plane. So movement tools for when you want to, say, move your point clouds closer to each other or properly kind of orient them with respect to each other. And then we have rotation tools. So these kind of circular tools also have handles that allow you to rotate, again, around each axis. I'm going to keep it as is, though. This actually gives me an opportunity to bring up the undo redo button, which is probably the most important function in the entire software, as it is in a lot of software. Control Z brings it up, again, like any other piece of software. If you do make a mistake, a deletion you weren't meant to, a rotation you didn't mean to, just hit Control Z. Quick Stitch is nice because it does have an entire list of all the actions you've done, and you can basically back up as many of them as you would like. So I can back up all the way back and go back to kind of where I was. I can also redo and apply them back. So very important function to kind of keep in mind. Next up, we have, let's see, the select tool. So this is going to be our main cleaning tool. It basically brings up a crosshair that allows us to select a number of points. These points can then be deleted or any number of functions, but this is mainly what we're going to use for cleaning out points. So if I click and hold, it creates a simple square selection highlighted in yellow here. If I just do a single click, I can actually make a polygon selection. And then I double click to complete that, and there's my polygon selection. So those are what we'll use for the actual cleaning of the point cloud. And then up here, these are all kind of tools under the select tool umbrella. We have delete. I usually use the delete key. If I do it here, delete, it deletes the data. Let me undo that. We have a cut tool, which is quite nice. If I wanted to actually cut, let's see. If I want to actually cut out a section here, I can select it, click cut. I'll call it wall. It will basically create a separate point cloud here that's called wall, and it's basically that section I've cut out. So it's good for kind of segmenting your data, I suppose, and kind of making it highlighting a certain area. For example, I could apply a different color map here. So quite a useful tool. Let me rejoin these just to simplify it, because I don't want them separate. Okay, so we're back to one point cloud. We can copy data, we can do an inversion. So if I wanted to invert, it's going to do everything outside my selection. Sorry, one moment. We have a level 2 selection option, which is actually very useful if we have, for example, like a surface. Let me show you a data set here. I'm actually going to go back to the Chicago data set. If you were here last week, we keep going over this data set that was collected in Chicago. Let me pull it in here. So this will be a good example of when I would use this level 2 selection. Let me change it to just a more interesting color. There we go. I'm just going to color it by depth. So we have a raw point cloud essentially here. So we have a lot of surface noise. If you remember, we can actually see the surface right here. I know this is the surface because I have a lot of experience with these systems, but also just because you can kind of see where the reflection comes in and where the actual data is down here. So if I identify the surface, which typically you can if you're in shallow water, and I just highlight the surface here, or as much of it as I can. Let me get a better one. Okay, so I've highlighted the surface. If I click this level 2 selection, just click OK. It's basically going to level everything to the water surface. So obviously the water surface is always your best level. If your tripod was on a slope, your data is going to be completely off level. So it's a good way to kind of level out your data if you have no other pitch roll data accompanying your scan. So I use that tool quite frequently to level out data. So let's go back to the dam area. Aside from that, these are a couple other select tools I'm not going to really spend much time on, but they can also be useful in certain cases. Now on the left here, I've been going back, and I know I'm clicking a lot here, so I'm not intending to create confusion. But on the left here is our project tree. So this is basically like our Windows Explorer, our main navigation area. So we have a number of items here: maps, surveys, events, lines. So the main one we're looking at here is under this toppings category. It's of course point clouds. So we have a number of things here. We have checkboxes. Checkboxes are basically a visible box. So not visible, checked, visible. if I wanted to not view the Chicago data set and view the one from Alabama, I can just uncheck it. Aside from that, though, there is a selection. So the point cloud that's highlighted is basically the point cloud that all your actions are going to apply to. So for example, if I have the Alabama data set checkmarked, but I have the Chicago data set highlighted, and I click my select tool and I try to select points, it's not going to work, right? Because my actual data set I'm viewing that's visible is not the one that's selected. So if I were to select the data set, it actually highlights it. Now I'm working actively with that data set. So important distinction to keep in mind. Really, that's the main thing over here. There is a properties window for nearly every item. I'll go over the one for the point cloud. So if I click on this point cloud, highlight it, we'll see a number of properties down here. The main ones here, we have point size, which again, I've adjusted up here. We have a easting, northing, and a Z, so we can actually specify a location. If we know the location of the point cloud where we want the origin, essentially where the sonar was to be located, we can actually just plug that in here and it will move it to that location. And then we have coloring. So we have a depth color mode, which we're in right now. We can kind of see the shallower depths at red and goes down to blue the deeper we get. We have solid colors. We can color by intensity, which isn't too obvious here. You can kind of see some different coloring on the more intense returns. That's useful in some cases, definitely. I'll mainly stick with depth coloring and solid coloring just to keep it simple. And then there's a number of color maps. So, color map, depending on what your application is, depending on your preference. I'm just going to stick with the default here, which is called Shire. Okay. So at this point, I've kind of gone over all the main tools. Again, there's a number of others, but they're not really used in my main workflow and generally in the main workflow, though definitely worth exploring within the Quick Stitch software if you were to use this software. So I'm just going to kind of jump right into the first step of processing, which is cleaning the point cloud. So as I've mentioned throughout this kind of 3D training series, these point clouds can be quite noisy, especially if there's shallow water, a lot of sediment, particulate in the water. They're going to generally require cleaning. Surface noise as well. In this case, there is a bit of noise around the sonar head here. You can see just kind of floating particulate. So I'll want to clean that out. There are some multipath noise over here. I went over this last week, but we have a solid wall here, and then we have actual returns beyond the wall. So these are multipath. These are where the acoustic signal is basically bounced all over the place and then returned to the sonar, essentially having the sonar think that there is an actual extension of the wall when in fact there's no wall behind here. So this is all garbage data behind the wall. So easy to clean that. I can even do 2D, kind of smash it down into a 2D plane, click my select tool, kind of line it up, delete. I can even get a little more tight. And there we go, already significantly cleaner. I'll clean out this kind of noise here really quick. Again, I can use the polygon tool, actually a little more flexible. Let's see what else I got in this data set. Just a lot of small little floating pieces. Now there is something important to keep in mind. If you do have objects like this object here, it's actually one of those spherical reference targets. I would not want to delete this. It is a floating object in the water column that's otherwise not really contributing to my data, but I am going to use it for registration. So you definitely don't want to delete objects you may use for actually registering the point clouds together. Afterwards, after the registration, you definitely can delete these in your kind of final scrubbing of the data set, but for right now, I definitely want to keep that in my imagery. So
yeah,
I'm going to do
if you followed our previous webinars, that reference target that Tyler's talking about is an artificial target that's placed in there to help with registration from point cloud to point cloud and make it more accurate registration, having a known target in those structures.
Right. Yeah, so I'm doing a very quick cleaning now, again, in the interest of time. Typically, I would spend a lot more time kind of scrubbing the data and making sure it looks as nice as possible. Also makes your registration process a lot easier. So the cleaner the data is, the easier you're going to have, easier time you're going to have kind of identifying targets and just generally doing your point cloud stitching. So at this point, I have clean the point cloud. I do want to mention there's kind of a newer tool within Quick Stitch. So if I right click on the data, go to Easy 3D Remove Noise. And there's a nice little tool here that can basically use a number of different algorithms and calculations to automatically clean the data. So for example, I have one that's distance to nearest point. If I click, let's see if I click add. There we go. So it's basically, let me see if I can get it to come up here. So I can set the parameters. Oops. Let's set it to, let's say 2 centimeters. It's just calculating. So we can kind of see a red and green view here. So basically the red points are going to be deleted. So based on the parameters I've chosen here, which is distance to nearest point, I've set a parameter minimum to maximum of 0 to 2 centimeters. So any point closer than 2 centimeters is going to be removed, and it's similar to the optimize function, but there's a lot more parameters you can specify and a lot more methods for which to clean the data. So it's going to delete out the red points here. If I want, I can click apply and OK, and it will automatically clean. So worth playing around with. I just want to touch on it briefly. Of course, I could spend more time on that, but unfortunately, we don't have time at the moment. So my next step after cleaning is to bring in my second point cloud, right? The one I want to actually stitch to. So again, I'm going to go to File, Add XYZ. I'm going to select 2, location 2. I'm going to say point cloud. You can see in the lower right, it has a load progress. It's basically importing all the points. And then there's our point cloud. So immediately we can see they're not aligned properly. They're not spatially referenced to each other properly. And in fact, the scan locations, the donut hole is stacked right on top of each other, which makes sense, right? Because they're by default, the origin is 0, 0, 0. So if I were to pull in 20 scans that were just default scans, they would all stack right on top of each other because they all have the same origin point. So this is the whole reason for stitching, right? Is because each scan doesn't know where the other scan is, and we as the operator have to tell it and have to actually stitch it itself to kind of get it in the correct location. So over here, I'll make the original clean point cloud invisible, and now I have this new point cloud. So again, repeat the step. I'm going to clean it. Let me get the coloring right here. Oops. It will work. There we go. So just bear with me a moment. I'm going to do another rapid clean. And again, there's going to be time afterwards to really scrub it again. This cleaning step is really just to make my life easier when I'm actually doing point cloud registration, just so there's not a bunch of mess and noise in here, just as I'm trying to, again, identify objects, things like that. Okay, that's good enough for now. These data sets actually aren't incredibly messy, luckily, so not sure why. It might have just been a deep enough area. Water surface was just not incredibly apparent. There wasn't much of a reflection, so it works for me. Okay, so now I have 2 point clouds. I'm going to remove the Chicago data set because that was just for the surface example. Okay, so we have 2 point clouds that are cleaned. I mean, quickly cleaned, but effectively cleaned at this point. First thing I like to do is basically move them, separate the two so I can really get them side by side. And again, I can do that with this transform tool. Brings up my little control here. I can just move it away. And this can really tell us, you know, kind of where each scan was located. So small area, scan 1 was here, scan 2 is here, which I can see over here. So I want to align these properly, and a lot of people would say, okay, you can simply just use that transform tool and just do it kind of by eye. Like I can use the 2D tool, I can kind of align these back walls, maybe rotate it a bit to line it up. Okay, and those look pretty aligned, but generally that's not gonna be a high accuracy alignment. That's gonna be kind of a quick and dirty alignment. So if you really want kind of more, I guess, survey grade results, that's where the software tools come in, using the software tools to really get a tight registration. I can see if I pull up my profile here, we can kind of see the walls are in line with each other, but are very much not perfectly in line. So as I move this along, you can see how far off the walls are, and even the bottom here, the bottom is quite far off. So I can keep kind of moving the point cloud and making micro adjustments by eye if I wanted to. But generally what I'll do is just use the software tools to make my life a lot easier. So let me separate these two again. So the primary tool we use for point cloud post-processing is this align tool, align tool. So if I just go ahead and select one of my point clouds, in this case, it's point cloud 1, which had its name changed. I'll call it location 1. I'm gonna click align, and it says, okay, what do you want to align this with? Well, I only have one other point cloud, so I'm going to align it with that point cloud 2. It brings up this point cloud aligner menu. So this is probably the most familiar to users who have used stitching registration software. This is the most familiar method probably. It's basically identifying objects within your scans that are shared between both point clouds. So this is where the importance of that overlap is huge. Having enough overlap between scans. If you don't have enough overlap, you're gonna struggle to find the 3 or 4 common points required by the software to properly stitch. So luckily there's plenty of overlap in these scans, as you can imagine. So we shouldn't have too much trouble finding our common features between the two. So in Quick Stitch, there's a point and a line, so I can identify common points and common lines. First thing I like to do, let me make this another solid color, just so we have two point clouds, 2 different solid colors. First thing I like to do is really just kind of look at one of the point clouds, see if I can find any kind of features that I can easily use for registration. First one that appears is kind of this tripod on the ground here. It's kind of difficult to see maybe from your end, but there's definitely a tripod here. Actually, let me, a little easier to see with depth coloring. So this is a great object. Is it in the other scan? We can easily check that. And in fact, it is in the other scan. So that's a perfect, kind of an ideal shared object between the two. So let's start with that one. I'm going to select line, and I'm going to say, okay, from kind of the base here to the top, I'm going to specify that as a common line between the two. So we can see it drew a line in one of the data set, and what it does is it automatically switches to the other data set, selects it, and says, okay, now basically designate the same line in this data set. So I just find the same object to the best of my ability, kind of do the same line. You can see it automatically sets the range properly, and I say that's the same object. So now I have a line pair. I can actually see it listed. It's A0, B0, so that's a pair. So we're going to need, the more pairs we have, the generally the better the stitching is going to be. So the more objects, the more surfaces we have that are common between the two, the better of a registration we're going to have. So let's look for more here. So we have this spherical reference target. This is actually hanging from the surface. There was some kind of catwalk or something over this area that allowed the operators to actually hang these targets. So what I usually like to do here is do a point, and I just like to do a point where kind of the chain hits the ball here, which is about right there. Again, we can kind of see it puts a little point there, and then it switches to the other point cloud. And then I want to look for that same object, which is actually right here. Not as pretty, but it'll work. You know, it's not an exact science a lot of time. The software is going to do a lot of the hard work, but you want to just be as close as you can with your point in line designations. Okay, so we have 2. Again, I need 4 or more to really allow the software to do anything at all. So a lot of shared walls here. So I'm going to look at these walls. If I kind of look from the top down, let's do 2D. You can kind of see the wall has a certain shape here. So what I'm going to do is go back to 3D. I'm going to select line, and I'm going to draw a line. Let's see. So this kind of column here is shared pretty clearly in both data sets. So I'm actually going to do a line here, roughly. And let's just go over and do the same line over here. There we go. And let's just keep going. So there's another column over here. Let's do kind of this outside corner from the bottom to some distance up. Do the same one over here. Again, the data is not as clear here, but that's okay. We're going to kind of get a verification of how good these point pairs are once we actually do the calculations. It's good to have multiple, say, for example, multiple lines on different surfaces, on different axes. So we can see I have a lot of lines along the vertical axis. That's great, but it would help the software to have a line, say, along the y-axis here. So I'm going to do a line on the section of wall between these 2 columns. Let's do it kind of, let's see. Actually, you know what? Let's do it on the front face of this column. Looks like a good place. I can do a line just at the bottom here. And let's do it here as well. Great. There could be more. Actually, let's do one more. I'm going to go back to this tripod. There's this front tripod leg here. I'm going to use this as an object. It's going to be less clear in this one, but we can see it right here. So sometimes it just takes practice. If you haven't dealt with point cloud data before, it definitely, you have to kind of train your eye to see in a 3D space. So it does take some practice, as any software does. So if it looks like I'm flying through it, that's just because I've used it a lot. So if I kind of zoom out here, I now have 1, 2, 3, 4, 5, 6 point pairs. If I go ahead and click this preview button, it's going to try to register the point clouds based on these pairs. So let's go ahead and do that. You can see it brought them together. Let me change the color again. Yeah, so we have a green and a blue. Location 1 and 2 are now registered together, and we actually get some values here. So we have this is basically an error value. So 12 centimeters for that pair, 12, 13, 14, 5, and 11. So the higher those numbers, essentially, the worse your point pairs are. So these are all pretty good. Generally, if I'm under 20 centimeters, I'm pretty happy with that. If I zoom in here on one of my pairs, this is actually the line pair I did kind of on the outer edge of this column. You can see the red is that error, is that 12 centimeter or 14 centimeter error. So if I did have a really awful point pair, what I can do is actually click it and I can remove it. And as soon as I remove it, it's going to actually, I'm not going to do it, but it's going to recalculate and re-register the point clouds. And you might get a better result by removing kind of a bad pair, or even re-designating a pair, so redrawing it. Maybe you just didn't really have it on that outer corner. If I were to remove it and redraw it, I might have a much better result. So you can kind of add more pairs real time here as needed. So if I were to do another one here, so it just added another pair. Did it improve my result? Maybe a bit actually, but you know, you can kind of add them and have it calculate the registration real time with each additional pair you add. So once I'm happy with these numbers and with just visually how it looks, I can even draw a profile. Just looking at this profile, it looks generally pretty well aligned. I'm going to apply this. Again, you can always undo. So if I just click apply, it's going to leave them in the location that they're registered in. And let's just move this profile around and kind of see how we're looking. So I can see here it's quite well aligned along the bottom. You can see even part of that object pretty well aligned. Our walls are a bit off in some places. You know, the further away from the sonar the data is, the lower quality it gets. So if we're trying to look way out here, we might find more misalignments. They actually look decent. If I kind of flip the profile wedge this way, I can kind of check the alignment here. Again, looks pretty good. Our blue and our green are overlapping pretty well. So if they weren't, then you just kind of repeat the process and just do it again and again and try to be more careful, and just keep trying to get a better result if you're not happy with the result. So at this point, it's kind of definitely more of a qualitative analysis of how our registration went, which is generally how I do it. You know, you can potentially do it in a more quantitative way, but that's really not my approach for the BB5000. I don't find that it's needed. So we can see what happened here is there was actually a new point cloud group created. So we have a aligned point cloud. If I were to open this up, it's just the 2 point clouds, still separate. I can still select and deselect, but they're now under aligned point cloud. What I'll typically do is I'll call this location 1 and 2, and then minimize it and say, you know, even color it the same. So let's just color it one the same color scheme. And now for all intents and purposes, it's 1 point cloud. If I wanted to make this change permanent, I can right click on the point cloud and go to merge. Now this is, you're unable to undo this action. So if I were to merge this to one single point cloud, I can't demerge it. It's just how the software works. So only do this if you're absolutely 100% confident that these are merged and will never need to be moved separately again. In this case, I am happy with them, so I'm gonna just click merge. I give it a second, and it's going to merge them to now 1 point cloud called location 1 and 2. So that's, in a nutshell, that's essentially the registration process. This data set, of course, is quite straightforward to do it with. Let me set this. Some data sets will be more difficult, some might be easier, but again, overlap is so critically important for this, making sure you have a lot of commonality between the scans and a lot of common surfaces. You can see how much easier it will make this step. So the next step I would do, I'm not going to do at this time, is to add in another point cloud, add XYZ. I would add location 3, and then I would just kind of rinse and repeat. So I would clean point cloud 3, and then I would stitch it to my new point cloud 1 and 2, location 1 and 2, and then just keep adding on point clouds for however large your data is. And then at the very end, you can do a final cleaning. Say you have just items you don't really care about. There's data kind of here on the edges that's not great. Again, because it's far from the sonar, I can actually kind of delete that and say, you know what, I don't really care about that. we're really just focused on this wall, on potential damage here. So I'm just want to keep this wall. You know, maybe I want to, whoops. Maybe I want to color this wall something else to highlight it. I can do the cut function. I can say north wall. I have a separate object here, and I can say, let's color this. Let's make this a different color map. Oops. So now we kind of see how we can highlight certain features and certain objects just to make them stand out. So just by using that cut tool. So this is kind of approaching where we would give our final deliverable. This is, in my opinion, not a final deliverable because it's been a quick training of this. I would obviously spend more time on this point cloud. But at this point, if we did want to make a deliverable, we can do, of course, if we did want to, like, say, export the point cloud, we can export it as an XYZ. You can send this to someone along with, for example, Blueviewer, free, you know, it's a free small point cloud viewer. Send them Blueviewer, send them the point cloud. They can install Blueviewer, bring in the XYZ, and just have a quick look, rotation, zoom in, zoom out. That's probably the best way to view point cloud data, as you can imagine. If you're wanting to do kind of more email or presentation, of course, you can do the screenshot function. We can say top view. It's going to save a PNG image. So we can pull it up here. There's our image. Pretty straightforward. Probably the most powerful, I think, is this video, is this kind of fly through tool. Blueviewer does not have this.
Before we jump into this, just as we get closer to the end of our allotted time here, if there's any questions, please add them into the question section, and we'll answer them as we go through this fly through section. And I can see that Tyler used the line and point technique, and I like to use the cloud to cloud technique. So there's multiple ways to register these data sets together. So if one technique doesn't work, you can use another. And also one thing I tend to like to do is when right before Tyler merged the 2 point clouds together, I have a tendency to highlight one point cloud and delete some points that are from the further scan to eliminate any, I guess, noisy data or data that's further away from the scan that's closer, so that you're not building I don't know what you call kind of haziness in a more defined area. If you can maybe highlight that and just show what I'm talking about there for a second, that would be.
That's actually a really good thing to bring up. That, let me see if I can, whoops. Let me group these two together. So for example, if I were to try to register this point cloud 3, so location 3, which is kind of right here. So we can see a lot of the points kind of overlap here, but for location 3, these points further away are not going to be nearly as high a resolution as these locations, which are actually much closer to this wall, right? So the closer the sonar is to an object, the better resolution you're going to get. So instead of kind of stacking points on top of each other, like we're doing here, for point cloud 3, I know the data on this wall is just not as good. It's much, it's inferior quality just because simply the sonar is further away. So basically, why would I want to stack these wall points on top of existing wall points I have that are actually very high resolution? The answer is I don't really want to do that. So once I register, what I would generally, or what John I think is mentioning, is he would basically get rid of these points. Is that right, John? Or
Yeah, that's exactly right.
Yeah. So just to prevent a lot of overlap. I mean, overlap is what you want, but sometimes you don't want so many point clouds stacking points on top of each other when really you have one location that has the best shot of an object, in this case the wall, you just want to keep those points because that had the best position. So you kind of have to make that decision based on your location, your object, and just kind of delete points as needed. That's a very, very good point. And as far as the registration, yeah, there is another method of registration. I don't use it as much, but this is another example of it's really processing is all about your own workflow. It's all about what tools you find are best, your experience with the type of data you're collecting. Even between me and John, we have slightly different methods. So unfortunately, I don't think I'll have enough time to go over that other method, but if you do have questions on it, you can definitely reach out and we can kind of show you how that works as well. But I did want to go through the fly through because I do think that's important. So fly through is essentially just your video making function. So it works by adding these camera keyframes. So these are basically adding camera locations around your point cloud. So typically, playing kind of my best director here, I like to start far above the point cloud. I like to add a keyframe kind of above it. Then I'll typically like to zoom in a bit, maybe from a different angle. Let's add another kind of keyframe, another camera location here. And then let's maybe zoom in a little further on, the reference object, maybe on the wall here, if this is the object of interest. Set another keyframe. And then from here, I just kind of want to zoom out and maybe get a nice plan view. And then finish from another zoomed out location. Okay, so I just clicked that button a bunch. Every time I clicked it, it actually made these keyframes here under camera path. So 1, 2, 3, 4, 5. And what I can do here is basically do a fly through of these keyframes. So if I just click cycle camera, it's going to actually cycle through quickly. Kind of does a weird flip there, which I can fix, but it's pretty straightforward, right? It's going to just fly between these. I can set any number of parameters. I can set the overall speed, travel time here. So if that was too quick, I can slow it down and say, okay, let's take maybe 150 frames to travel the entire path. Now, if I cycle it again, it's going to move much slower, which is kind of makes more sense. Generally, you don't want it to be flying through the point cloud too quickly. So that's travel time. For each individual point, you can have a pause time. If I wanted it to pause on this wall for longer, I can say, okay, pause time. Instead of just 20 frames, let's pause here for 50 frames. It's just going to pause in this location a little longer. And then I can kind of change heading and pitch. So for this one, I actually want it to be reversed. So I can just do the heading at, say, 180, whoops, 270. It will flip it around. Now it should have kind of a more natural cycle as I go. Yeah, so now it's kind of pulling out and then it zooms out to our final location. So let's say I'm happy with these, happy with the fly through. It's showing some features, zooming in on some potential damage, whatever we want to look at. Let's go ahead and just record the video. Just right click on the path, click record fly through. Typically, I just like to record the 3D window, not the entire software window. This typically comes up. I just say click continue anyways. Ready for recording, click go, and we're going to record here. I should have sped it up here because this is going to take a while, but it probably looks very choppy. That's okay because what we're doing is we're actually recording a raw video right now. So the final resulting video will be a lot smoother. I want to stop this because we don't have enough time to have it walk through the entire thing. So I don't know if I can stop it mid-recording though.
Do you have another video, maybe not of this data set, that you can just show a fly through?
I should. Let me see what I got here. By the time I find something, it's definitely going to be done. So let's see. which one is this? Alabama. I actually don't, surprisingly. It's almost done though, so we'll just let it finish up. Aside from this, like I said, there's not a lot. There's some other functions that are worth highlighting. I went over the main workflow and I went over what functions are most important in my workflow. But as John already mentioned, there's other functions that you might use for registration or for cleaning. Okay, it's just packing. So yeah, it's really it's a full day training, kind of condensed into almost an hour now. So you can kind of see where there's a lot more to go over, but really this is a good foundation and really just kind of lays out how a post-processing of PV5000 data is going to look. Regardless of what software you're using, the same basic workflow is going to apply. All right, let's save it. Let's save it right here. Let's call it fly through. Okay. All right. So we have now, whoops. We have now the fly through. It's actually here. It's an MP4 file. So if I were to open it up using a VLC player in this case, we can actually see the fly through, and it's very smooth. It's not as high a quality as the raw point cloud, of course, because it's a condensed video, but it's an incredible tool for emailing data, for just showing a quick overview of, hey, this is what we collected, this is what we're looking at. This is the area we're worried about that needs further inspection, or that needs repair, or whatever you're doing for your application.
So Tyler claims that it's smooth. It's not coming through very smooth on my screen. It might just be the connection of the video, but it did look like it was chopping as far as the the time scale goes. So.
Okay, yeah, that's the go-to meaning. I promise you'll have to take my word for it. It's very smooth on my screen. So I guess it's just not coming through the webinar, but it definitely comes through smooth. And yeah, I mean, I can send this if anyone would like this fly through. I can definitely send the file on through.
Yeah.
Yeah, I think for now we're pretty much at the end of our time.
Yeah, we're at the end of our time. So again, if anybody has any questions, you can enter them in. Tyler, do you have the PowerPoint open with our contact slide at the end? You can throw that at the end, and with our contact information, and we'll answer any questions direct. Otherwise, thanks everybody for joining. And this video will be recorded, and you'll get an email notification with it as well for future reference.
All right, yep. Great. Thanks a lot, John. Thanks, Tyler. I don't see any questions coming in here, but if you guys have any or think of any questions after we wrap this up, just email me. I'll be happy to pass them along, or actually send the contacts up there. Contact Tyler or John directly. They would be happy to answer any questions that you have. Otherwise, we will follow up with the recording. And Tyler, if you and John do want to include that video, just let me know. I'll be happy to post that for easy download. Sure. So, okay, wonderful. Well, thanks for this full series. Really, really informative. I'm sure this is going to be a tool that people are going to go back to reference as they move along. So thank you everyone for your time today and for joining us, especially those of you that hit us for all 3 sessions, which is fantastic. So hope everyone has a wonderful day, and everyone take care.
Thanks everyone.
Take care everybody. Bye-bye.